Hey everyone, welcome back to day three of confidence intervals for population proportions. We're going to take a look at a different angle of the problem today where we can actually determine the sample size that we need to achieve a particular margin of error. All right, so if you're looking through the homework, you probably ran into a problem where it said, hey, determine the sample size if we want a margin of error of 3% or 4% or something like that. And it's really cool because you can actually set your margin of error to be a certain percentage, and you can control that margin of error by the size of the sample that you take. So when researchers do this kind of stuff, they don't want to have to sample any more people or any more subjects than they have to because sampling costs money and it takes time. So they try and get away with as small a sample as possible in most cases, especially when you're working for a big company like Coke or Pepsi or something like that. All right, so let's take a look at this scenario and you'll see what I'm talking about. So it says, lucky you, you have recently graduated from college with a shiny new degree in statistical science and you land a job at Coca-Cola. The first thing they ask you to do is to figure out what proportion of people prefer Coke to Pepsi so they can see how well they are competing with their competitor. All right. So it says your boss demands a 95% confidence level and specifically wants the margin of error to be 5%. So this is a situation where we're setting the parameters of our confidence interval. We want a 95% confidence interval. We want the margin of error to be 5%. So your boss tells you that they've done this previously, and the proportion was estimated to be about 75%. So at some point in the past, they did this exact same study, and at that point, they estimated the proportion to be 75%. So now we kind of fast forward to the future. You've got this job. We want to know if that proportion of people who prefer Coke to Pepsi has changed from 75%, and we'll be able to see that at the end of this problem. Okay, but first we need to determine how many people we're going to go sample. How many people are we going to go ask, hey, do you like Coke or Pepsi? All right, so let's start with a little bit of what we know. Okay. So we'll kind of start here. When we start a problem like this, it is okay to use the previously known or an estimate. All right, so they told us in the previous study that the point estimate from the previous study was 0.75. So we're going to go ahead and use that. Our standard error is a question mark. We don't know what the standard error is because we don't have a sample size to compute it. All right, so I'm just in this box for right now, we're going to put no sample size. Right, and without that, we can't calculate a standard error yet. All right, critical value. So we wanted a 95% confidence level. So I can go ahead and write that down over here. So we got a 95% level of confidence, which tells me that the alpha value is going to be 0.05, which means our alpha over 2 value is going to be 0.025. So this is the area that's going to be in those tails. So to figure out my critical value, I'm going to do an inverse norm with 0.025 comma 0 comma 1 to figure out what those boundary values are. And we actually did this in the previous set of notes for a 95% confidence level. We found those boundaries to be 1.96. So this is going to be our critical value, or Z alpha over 2. Okay. Our margin of error, we set that. Our boss told us it has to be 5%. So we're going to say margin of error equals 5% or 0.05. Okay, so these are the things that we know. And really the question mark over here is the standard error, and it's the standard error that contains our sample size, which is what we're trying to find. Okay, so let's see if we can set something up here, maybe use some of our previous skills from algebra to figure this out. All right, so we're going to start with our margin of error formula. All right, so recall from the previous notes, we had said that to find the margin of error, we have to take the standard error times the critical value. Okay, so we take Z alpha over 2 and we multiply it by the standard error. This is our margin of error formula. We know certain parts of this formula already, so we're going to fill in what we know about this thing. So we know that the margin of error has to be 5%, so I'm going to go ahead and put in a 0.05 for the margin of error. We know that our critical value is 1.96, So I'm going to plug that into my formula here. And then I'm going to put my standard error formula in here. So recall that our standard error formula requires us to take p hat times 1 minus p hat, divide by the sample size, and then square root. Okay? So this is the standard error. This is how I would calculate it. And I'm looking inside of that standard error formula, and I'm thinking, well, I know p hat. We have a 0.75 that we can use here. Okay, so I'm going to say 0.05 equals 1.96 times the square root of 0.75 times 1 minus 0.75 all over the square root of n. I'm sorry, all over n, right? That's all inside of the square root. So when I look at this now, what I have is an equation with the only thing unknown being the sample size. So this is an equation that I can solve using algebra. So I'm just going to start that process, right? So remember back to algebra 1, we want to get n by itself. So I'm going to draw my line here separating my two sides. And I'm going to start moving things around until I can get n all by itself. And once I do, I'll know the sample size. So I'm going to start by dividing both sides by 1.96. So I'll divide this side by 1.96, and whatever I do on one side, I've got to do on the other side. All right, so now that we have divided both sides by 1.96, on the right-hand side, the 1.96's will cancel. Right, so all we're left with is that big square root. And I'm going to simplify a little bit inside of that square root. So if I do the 0.75 times the 1 minus 0.75 here, we'll get a 0.1875. And that'll be 0.1875 over n. And then over here, I'll go to my calculator and divide 0.05 by 1.96. Okay, get rid of this thing here. Turn this on. Come on, there we go. Yeah, let's get out of here. There we go. We got 0.05 divided by 1.96. And we see our number there, 0.0255. So I'm going to write that down. And carry 4 decimal places for now. Again, in my open math, you'll need to be maybe a little bit more careful with the decimals and make sure you carry a lot of decimal places in the intermediate steps here until you get to the end. Okay. Now I want to get rid of that square root, so I'm going to have to square both sides of my equation. So I'm going to square over here. I'm going to square over here, which means the square root and the square, they cancel each other out. So we'll have 0.1875 divided by n. And over here, I'll go back to my calculator and I'll just square root that answer I'll just square that answer that I had before. And I get this 6.5077 e to the negative fourth. And I'll just write that down as I see it. Okay, don't worry about doing anything too fancy with that yet. I'm just going to write e negative 4 here. Okay, and that's just that number that came from our calculator. Now we're almost there. This thing is a lot less nasty right now. We got rid of the square roots. We just have to get this n by itself. So at this point, what you can do, just a quick solution to get to the end here, is to do a cross multiplication. So you'll get n times the 6.5077 e to the negative fourth equals 0.1875. And I'll continue over here. So to get that n by itself at this point, I have to divide, right? I have to divide by this 6.5077 e negative 4 on both sides. Okay, so that way they cancel. So we'll get n equals 0.1875 divided by 6.5077 e negative 4. This is the calculation I need to do to get my sample size. Okay, I'm going to go back to my calculator and I'm going to take 0.1875 and I'm going to divide it by my previous answer, right? So I'm just going to hit divide and I'll hit second and then you see ands there in blue, so I'll just do that. That way I don't have to worry about rounding or trying to do an E-4 or anything like that. It'll just insert it for me automatically, and I'll hit enter, and there's my final result. So I got 288.12. So this is supposed to be my sample size, but we can't sample 288.12 people, so we're going to round up to the nearest whole person. So we'll just say that our sample size is going to be 289. Okay, so there's the sample size that I'm going to be working with. All right. A little bit of algebra there, guys. All right. So just if you need to watch that a couple of times, that most of the steps are going to remain consistent for every problem that's like this. So don't get intimidated by the algebra. We really didn't do anything too complicated there. But watch it a couple times. If you have questions, post in the forum, and I can try and answer those specific questions for you. All right, so let's continue on. We've got to actually do a confidence interval here. So now we've got the sample size of 289. So we kind of go through our requirements. We need to make sure that this is going to normalize. We have to make sure that the number of successes and the number of failures is bigger than 10, okay? So I go out as the researcher working for Coca-Cola. I find 289 random people. I ask them what they prefer. I find that 173 of them prefer Coke over Pepsi. Okay, so what we find here shape-wise, we had 173 successes, right, which is bigger than 10. And there's 116 people left over that did not prefer Coke over Pepsi, and that is a failure, so that is still greater than 10, right? Both of my successes and failures are greater than 10. So this will normalize just fine for us. It gives us the ability to use that inverse norm when we calculate our critical values. Okay, our center, right? So remember, our center is going to be our new point estimate, right? So that's going to be 173 over 289. This gives me a new point estimate of 0.598615. And this is our p hat. Okay. This is our new p hat. All right, so remember before in the previous study it was 0.75. Now it's 0.598615. That's our point estimate. So initial perception here is that the percentage of people who preferred Coke over Pepsi is going down. All right, this is not that close to 0.75. All right, now our spread, we have to recalculate our standard error. Now that we have our sample size, we can do that. So I'm going to take this 0.598615 and I'm going to multiply it by 1 minus 0.598615, divide by my sample size, which is 289, and then square root. And if I do that calculation correctly, I should get 0.0288. 340. Notice I'm carrying a lot of decimal places, or I'm trying to remember to, so that I don't have any errors at the end. Okay, so here I specifically want you to go ahead and use the calculator to figure out your confidence interval. We have gone through our requirements. We calculated our center and our spread. So let's use the calculator to finish this off. But again, be wary of becoming too reliant on this calculator here. Okay. So let's go to stat. We're going to go over to test. Oops, wrong test. So stat, test. We'll do z-test later, don't worry. We're going to do, today we're going to do this one prop z int. Hit enter. They want to know the number of your successes, so that's going to be 173. Our sample size was 289. And our confidence level was 95%, so that's all we need for this. And there's our confidence interval. So we've got 0.5421. We're going to write this in interval notation first. 0.5421. And it was 0.65513. Okay. And if you want, you can write that as percentages as well. So you could say 54.21% and 65.513%. I've never figured out why they carry more decimal places in one versus the other. Uh, Kind of weird that Texas Instruments does that, but that's what they do. So, but either way, there's our new confidence interval with 95% confidence. Okay, and if I were going to write that in inequality notation, we would say, well, the actual population proportion, right? So no hat when we do this one, no p hat, just p, right? Because we're estimating the actual population proportion. We're 95% confident the actual population proportion is somewhere in between 54.21% and 65.513%. Okay. So the next thing we want to figure out is what is our margin of error. Now we could go and do the margin of error formula again with our known sample that we just found, our known sample size, or we can just kind of figure it out from this. Okay. So remember that our point estimate was 0.598. So 0.598615. That is supposed to be the center or the midpoint between these 2 points. So the distance from the point estimate to either one of these boundaries, that is the margin of error. So if I just take this point estimate, 0.598615, and I subtract the 0.5421, that gives me the distance between the center and one of the boundaries. And that distance, if I did this right, I got 0.05615. And this is my margin of error. Okay. Now remember, the boss demanded a 5% margin of error. This is pretty darn close to 5%. We didn't land right on 5% because we did some roundings. We went from 282.12 and we rounded that up to 289 when we did our sample size. Okay, so that's why it's a little bit off. The boss is going to be okay with that. All right, so we got right at about 5% margin of error, which is what we were aiming for there. Okay, so now that we know the margin of error, I want to write this in a plus minus notation. So I'm going to take my point estimate. I'm going to say 59.8615% plus or minus 5.615%, right? So this is my plus minus format for the confidence interval. And then we would interpret our confidence interval using a complete sentence, okay? I'm not going to write it out because I really suck with this pen, but I'll say it, right? We are 95% confident the actual proportion of people who prefer Coke over Pepsi is somewhere in between 54.21% and 65.513%. Okay, and you can see all of those up here with how that's written. Okay, but that's what you would write here. Use a complete sentence in English. How would you explain it to people that really don't know about statistics? All right, and the big question, has the proportion changed? I would definitely say yes, the proportion has changed since the last time they conducted the study. It was at 75% before. They estimated it to be around 75%, and now our confidence interval is telling us it's somewhere in between 54 and 65%. All right, so I would say that the preference for Coke has gone down, and we probably need to do something on the marketing end to get Coke to be more popular again. Okay. All right, that concludes this lesson. Hopefully that helps out with some of those homework problems. Keep plugging away at it, guys. Let me know if you have questions. All right, have a great day.